All right, good afternoon, everybody. Welcome to day 2 of Build, or the rest of day 2 of Build. My name is Chris Reisner, and today we're going to be talking about building cross-platform apps with Windows Azure mobile services. First thing I'll do is tell you a little bit about myself, and then we'll kind of get started. So, as I said, my name is Chris Reisner. I'm a technical evangelist on the Windows Azure team. I really focus specifically on mobile connectivity into Windows Azure, and even more so, a lot of on the iOS, Android side of things, with some of the Windows and Windows Phone stuff thrown in there. My Twitter handle and my website are there. As you can see, I wasn't very creative when I created those. Previously, before I started doing mobile development, though, I did about 5 or 6 years of pure .NET development, so websites, smart clients, kind of everything across the board. I grew up in Michigan. I now live in Washington, and I'm actually a co-organizer of the Seattle Google Developer Group there. So today we're going to talk about options you have for building apps. And then we're going to talk about building apps with mobile services. We're going to go through some of the features of mobile services, and then at the end we'll have time for questions. Now, if you've seen a presentation on mobile services before, we're going to cover a lot of the same concepts, but you're going to see them put to use probably in platforms or in demos you haven't seen before. There's going to be stuff, if you're just a .NET developer, you'll probably see some code you're not familiar with, or if you're a Java developer, you'll see some C# code you may not be familiar with. I'm going to try and walk through a lot of the code, so it should be pretty easy for you all to pick up. So, what platforms are we building apps for? Now, certainly we're building stuff for the Windows ecosystem, for Android, for iOS, and then HTML and JavaScript websites and web applications. When we talk about Microsoft, we're talking about Windows Store and Windows Phone apps, as well as other platforms like ASP.NET and pure Windows desktop applications. When we talk about web and when we talk about Java, it's not just I'm building something for maybe one system. It's I'm building stuff for a lot of different browsers, or maybe I'm building something for Google's Android versus Amazon's Android. And then on top of that, there's some other options we've got. So there's stuff like Mono, which allows you to develop iOS, Android, as well as Windows applications, all using C# as opposed to having to know a specific language for each platform. And there's also stuff like PhoneGap, where you can build a HTML JavaScript application and basically embed it in native apps. So instead of having to know, again, languages and systems for each one, you just put it in HTML.js, and PhoneGap kind of figures out the rest for you. That's a lot of platforms and a lot of stuff. On the good side, though, is that mobile services are going to have support for all these. There's different ways and different languages that we use for each of these, as I just mentioned. So we've got everything from C#, Java, and Objective-C to specifically HTML.js and the PhoneGap and C# and the Mono. As far as which one you should use, that's a question we're not going to talk about today because it's different things for different scenarios. It's kind of up to you to decide which of those frameworks you'd want to build an application in. But like I said, mobile services supports all of those. Mobile services is a backend as a service. What that means is that you can spin it up, and instead of having to code, test, deploy, manage, and update your own backend, you can just turn this on, and you get access to a ton of features without having to do all that work, so you can really focus on the client experience. So with mobile services, you get stuff like structured data storage, push notifications, user authentication, as well as data authorization, server-side logic, the ability to scale your service. So today I'm testing, I only need to support 10 users, but tomorrow I go live and I need to support 1 million users. Instead of having to redeploy your own machines, you just scale your service. The logging and diagnostic, kind of insight into how your service is performing, how your backend's working. And then also the ability to do backend processing, which is used by something we call the scheduler. So we're going to go ahead and get started with a demo of HTML.js. And what I'm going to do is I'm going to hop over here to my Surface, and I'm in the Windows Azure portal. So I'm going to go ahead and create a new mobile service here. That looks not terrible. Okay, so we'll just call this build MS, and we'll see if the name's available. It is. I'm going to choose to create a new database. As you can see, if you weren't aware, there's now a free 20 megabyte SQL database you can use. So since there's now a completely free tier of mobile services, along with that, you kind of have really a free across-the-board experience when you're just developing with mobile services. So we'll just choose Wes, and I'm going to enter my credentials for my database. It's going to create that. Now, mobile service is built off of Node.js. It's kind of running in a Node.js runtime. And it's also running off of or built off of Windows Azure websites. And it can do that because websites supports Node.js as well as a number of other different web technologies. Underneath all that, it's running off of cloud services. So there's kind of a lot of underlying architecture here, but as I said, the idea is you don't need to know or concern yourself with how that works. You just turn it on, you wait about 20 to 30 seconds, and it's done, and then you can start taking advantage of all those capabilities we mentioned. So we'll give it just a second longer, and hopefully it'll finish. There we go. So I'm going to go into my service, and the first thing we get is this quick start screen where we can choose our platform. Now, one common misconception is that you have to choose a platform, and then that's what you're connecting to the mobile service. As you're going to see today, though, we can connect a lot of different applications to the same mobile service. So today we'll start with doing Windows Store. I'm going to go down here to the Create a New Windows Store app guide. I've already got Visual Studio installed. I'm going to tell it to create my to-do item table. And what's happening here behind the scenes is it's actually spinning up a REST API. And that REST API is how we talk to our mobile service via the SDKs. So it's created that. I'm going to go ahead and download that. There we go. All right, so I'll go ahead and extract this. There we are. Now, I'm showing you the HTML JavaScript Windows application for a very good reason, and that's because after we look at this, we're going to then look at the actual pure HTML JavaScript project template, and it's going to look very, very, very similar to this. So let's start by just running this application locally. And all the quick start applications are basically to-do lists. So whichever one of those platforms you start with or you pick, you basically get a to-do list application that really demonstrates how to do structured data storage. So I'm going to put some stuff in here. We're going to say fly to San Fran. We'll say, let's see, go to build. What peer is the party on? Is it 49, 54? 48? Okay, so party on 48. All right, so we've got our, our to-dos in there. We've got stuff we're going to work on. If we go back to the portal and we go up to the data tab, we'll see that it's added all that data there. So behind the scenes, the mobile services SDK is talking to that REST API that was generated. It's sending JSON data over. Mobile services is looking at that data and using something called dynamic schematization. It's basically creating the columns for us. So I don't have to know my schema or figure out what sort of column types to use. Mobile services is going to handle that for me. If I go back here and I say, yep, I already flew to San Francisco, and I refresh my data, it's going to show up as that's now true because it's just sending that updated item back to my mobile service. So if we close this and take a look at some of the code. So this is an HTML JavaScript application. So we've got CSS, which is kind of like the style, like how should things look. We've got our HTML, which is just basically HTML. I think everybody's probably pretty familiar with that. And then the JS is really what we want to look at. So we've got this mobile services JS file, and that's the actual mobile services JavaScript SDK. If you look inside that, it's going to show you how we actually connect into our mobile service, how it makes all the REST calls, how it deals with making a connection, all that fun stuff's in there. We'll just look at the default JS, which is actually the kind of the code that my application's running on. And the first thing we have in here is we create a mobile service client. And we do that using the URL of our mobile service and then the application key. If I go back over to my mobile service in the portal, I go to the dashboard, go to Manage Keys, we'll see that the application key is there, and then there's also a master key that we'll talk about a little bit later. Now I want to highlight this because what you see right here, we're going to see in every other application demo we're going to work on today because they're all going to connect to the same mobile service, which means they're all using the same URL and that same application key. After that, we create we get our access to our table using the client and then just pass them the to-do. And then down here, this is kind of where we start to see some of the differences between the HTML.js application in the Windows Store and the pure HTML.js. So here we're using stuff like winjs.binding.list, and that's kind of what's going to bind our to-do items to our visual lists. It's going to be a little different, but once I explain why the HTML, the pure JavaScript is different, it'll make a lot of sense. Down here, we've got methods to insert an item, which we'll look at how it's called in just a second, because realistically, it's very similar to how the update works as well. When we actually read an item, this is how, or rather, when we do a read, this is how we specify what our filter is. And it's basically, we're creating a JSON object that acts as that filter. Behind the scenes, that gets converted into an OData filter on the query string. This is a really good example of how some of the things are different between different SDKs, because depending on which platform you're working in, things are kind of set up to reflect that environment, or that that development paradigm. So if we look at the same thing in .NET, the where clause is actually more like link, because that's kind of a usual thing when you're doing .NET development to use link. If you look at it in iOS, it uses something called a predicate, which is basically a way of creating a where clause. So it's a little different, but appropriate for each programming environment. If we go down here, when we actually add an item, we just call that insert method, and we basically create our JSON on the fly. This is another example of how things are different between each version. So if you look at the HTML.js, everything's kind of JSONified. It just uses JSON. If you look at the .NET application, it actually uses a strongly typed item called a to-do item. A little later on, when we look at an Android application, we'll look at the actual strongly typed code that it uses there. Behind the scenes, they're all converting things back and forth from JSON, but it just has the ability to kind of help you out so you don't have to just do pure JSON all the time. So I'm going to hop over here, and we're going to look at the same thing for the HTML application. So I'm in the portal over here. I'm going to go into HTML JavaScript, and I'm going to create a new HTML app. I already created my to-do item table, so I don't need to do that again. Now I can just download the application locally. So I've downloaded that, and I'll extract it. Now, in order to get my local web server to be able to run that site, I need to change the permissions on it really quickly. So I'm just going to do that there. Now that I've done that, I can go to localhost/buildms, and we're going to see those same to-do items are here. So let's just say test from HTML. And it's going to add that. And if I go back over to my Windows Store app, it's going to show the data is there as well. So the next thing I really want to do, though, is I want to take this and embed it into PhoneGap. So PhoneGap, like I said, is HTML and JavaScript, and it's kind of the same, essentially the same application code, no matter which platform you put it on. Well, this HTML JavaScript library that I can run as a website here, or I could push out to Windows Azure websites or really host anywhere, I can take pretty much that exact same code, put it in my PhoneGap app, and it's going to run. So the first thing I need to do is I'm going to create a PhoneGap application. And I do that using a command string. So when you download PhoneGap, it gives you all these command scripts that basically make it really easy to generate a PhoneGap application. So I'm just going to specify some properties here. That's going to create my application. Now if I go over to my PhoneGap library, oops. Just going to navigate there. So I've got my iOS application here because I generated an iOS application. I could have just generated an Android one or another platform one with the same sort of command line interface. So if I run this really quickly in the simulator, we're going to see that it really doesn't do much right now. It just says, hey, I'm working. It says device is ready. It says device is ready because when you do PhoneGap, the idea with PhoneGap is, like I said, same HTML JavaScript, but you can do it on all the different platforms you want. But the beauty of it is that PhoneGap provides JavaScript libraries that hook into the hardware capabilities on each of those platforms. But before you can actually access that hardware, you have to wait for this device ready call. And if we actually look at the code, we see that we've got all this PhoneGap stuff right here that we don't need to look at because it's kind of stock and we just use it inside our application. And then we've got this www folder. And this contains stuff that is very, very similar to what we have in our WinStore app. So we've got our CSS folder here. We've got a JS folder, and then we've got an index.html. In our index.html here, not much here. We basically just have some stuff where we show the device is ready, and then we reference some JavaScript files. If we open up the JS, again, there's a device ready event, and when it's called, we call this received event, and then that's when we actually show that device is ready inside the simulator here. So what I'll actually do now is I'll go back to my build MS, my HTML site, and I'm going to open up some of this in a text editor. So in here, the first thing I'm going to do, I'm just going to copy over my CSS because I want my PhoneGap application to look the same way. So I'll go into index.css here. Then the next thing I'll do, go into my index.html. Again, this stuff is really similar to what the WinStore was. The one big difference between this HTML.js and the WinStore one is a lot of that binding. So in the WinStore, when we did that WinJS.bind stuff, here we're actually building out HTML kind of directly. So I'll go down here. I'm going to copy the body of my HTML from the HTML app, open up index.html, and I'll just go ahead and replace everything there with what I've got here. Now, the next thing I need to do is, in the HTML app, it's referencing jQuery and it's referencing the mobile services JS file, but it's doing so remotely. When you build a native application, at least for iOS, and I think for Windows it's the same way, you can't pull down remote code and then execute it. It's a no-no, and it will get you in trouble. So what we have to do is we have to take these files and basically drop them into our application. So I'm going to go ahead and add 2 new files first. So we'll say jQuery.js, and we'll add another one for mobile services. And now I'm going to go into my HTML file here, and I'm just going to grab these paths, and I'm going to get that source code and basically just put it in my project. So just for clarity's sake, I'm not going to grab the minified version because I kind of want to see what I'm working with. So I'll go back over here, and I'll open jQuery. I'll drop in that code. Now I'm going to grab my JavaScript file. And you'll notice here that it's actually referencing this JavaScript file directly from my mobile service. So when you spin up a mobile service, it automatically exposes this JavaScript file for you to access. So I'll copy this one as well. And I'll save that. The last thing I need to do is actually copy over the application code, my JavaScript. So inside here, the first thing we've got, again, is the mobile service creation where we pass in the URL and the application key. It's over here, but it's there. Same stuff because we're accessing the exact same mobile service. We then call getTable, get our data, and then this is an example right here of where that's a little different. So instead of calling win.js.bind, we actually build the HTML. Now, there's nothing to stop you from using a library like Handlebars or I think Ember or stuff like that, where you can do templating in those and basically make it just as kind of simple and clear as it is in the Windows stuff. So I'm going to go up here, and I'm just going to copy all of this code into my PhoneGap application. So I'm going to go to index.js, and I don't really want to do anything because I don't know if I'm going to use some capabilities of the hardware here. I'm just going to put this into the same event that gets called once the device is ready. So I'll delete all the built-in code, and I'm just going to drop in that exact same code from my JavaScript project. Now if I run it, so we've got our... Oh, you know what I forgot to do? Sorry about that. So one thing I did forget to do is in here, I'm not actually referencing any of those JavaScript files. Let me go ahead and add that really quickly. So we'll say jQuery.js and then mobile services.js. Now we'll run it. And we get the same to-do items here. So if I say test from PhoneGap, and I add this item, and then if I go back to the portal and I refresh, same data, all there. It's going to be there on all 3 applications I've done so far because they're all sharing a common backend. They're all sharing a common data source. So really what we just looked at was how mobile services work with structured data. And that structured data, again, is powered by SQL database, but at no point in time do we ever have to specify columns, data types, or relationships, anything like that. It kind of figures that out for us. One thing you can do, especially when you're doing testing and developing, you can actually use the same database for multiple mobile services. So if you don't want to have multiple databases, you can put all the data in the same database because whenever you create a table, it prepends the name or the schema of that table with the name of your mobile service. So in this case, when I created my to-do item table, it was actually creating a build ms.to-do item. As far as data management goes, there's that Windows Azure portal that we just saw the data in. From there, you can see all the data as we looked at it. You can delete individual rows, and you can truncate or delete all the data in a table. If you want to get more advanced, there's a Silverlight SQL portal that's linked from the Azure portal that gives you kind of more of a DBA perspective / more full control. There's a SQL Management Studio, which is the Windows tool to run, basically do database administration. Then there's the REST API that we generate when we create a table. We can basically use that for any sort of data administration we want as well. There's also command line interface tools available for Bash and PowerShell, and we're going to look at those a little bit later. So, like I said, REST API is generated whenever you create a table, and this is basically the path. So right now, my to-do item table is basically at buildms.azure-mobile.net/tables/to-do item. And all of these operations, it's all common HTTP stuff, so post, get, patch, and delete, and there's the URL path. It's really important that that I'm highlighting this because this means that you don't have to wait for an SDK to start talking to mobile services if you're working with something that we don't have an SDK for. So for example, if you were using Ruby and you wanted to talk to mobile services, you can do it because it's just talking to a REST API or anything else for that matter. When you do send data over, using that dynamic schematization, it inspects the JSON data and says, oh, the value on the left is this type. I'm going to create this in the database. And that dynamic schematization is something you can turn on and off. So when you go to production, you don't want to risk adding new columns. You can just shut that off. In addition to creating a REST API whenever you generate a table, there are also server-side scripts that are generated that basically intercept any request against your table. As I mentioned earlier, mobile services is built off of Node.js, so these are essentially Node.js-style scripts. By default, all they do is pass your request through into the database. So if you're doing an insert the data. If you're doing a select, do a select statement on the database. But you can customize that logic to basically do whatever you want there. There's a lot of built-in modules, in addition to some enhanced functionality we just recently launched that I'll talk about later. But some of those built-in modules are stuff like requests, so you can do web requests to third-party services, push to actually do push notifications down to your applications, console for logging, MS SQL for doing custom SQL statements and calling store procedures. Status codes can be used to respond with a status code other than what's inspected. So if you do an insert, the normal status response is a 201, but if the data is invalid, you can use that to return a 500. The Azure module can be used to access stuff like table storage, blob storage, and service bus. And then there's a number of partners we've got, so those are kind of listed on the right here. So stuff like SendGrid, Pusher, and Twilio that you can get access to via the Windows Azure Store, and then they have modules as well. So, for example, you can use SendGrid to send emails. Pusher can be used to do WebSocket-style communication down to all the native clients as well as to HTML, JavaScript applications. Then Twilio can be used to do send text messages. So the next thing we're going to look at is just adding a little bit of server logic in. So what I'm going to do is just put some validation on the data and make sure that whenever I save my to-do item, it's at least a certain number of characters. So I at least know I've got some information. So I go back to my to-do item table and I go to the script tab. First thing I see is the insert script. And like I said, by default, all the scripts do is pass the request through to your SQL database. So this request.execute is basically saying, whatever came in, just do it. And this is where I can kind of hijack that and kind of do customized stuff. Now, as parameters for the insert, I get item, which is the actual JSON data that's coming across the wire. I get a user object, which right now all it says is the user is unauthenticated. But we're going to look closer at that a little bit later. And then, again, the request is just whatever they actually wanted to do. So inside here, I'm going to look at the item's text property. I'll check it at its length and say if it's less than 5, we'll call respond on the request. So don't execute the request, just respond. We'll use the status codes module to get the bad request status code. And then we'll say your to-do must be 5 characters. Otherwise, if it was, then we'll just go ahead and execute the request. So I'll save that. Now I'll return to my PhoneGap application here, and I'll just say ABC, and that shouldn't actually work. And it didn't. Down here we've got this bad request 400, and if we actually, well, I didn't mean to do that. If we actually looked at the code in our, well, if we actually look at the code behind and actually intercept that JavaScript, we'd actually see that the error is actually getting returned. And just to show you that the same functionality is still working on my website, if I go in here and I do the same thing, again, we get that bad request code. The same thing's going to happen on my Windows Store app because they're all sharing the same common backend data validation now. So that's how easy it is to kind of add in some customized logic into your scripts. The next thing we'll talk about is push notifications. Push notifications basically work the same way no matter which platform you're working with. So you have a client that talks to a push provider and says, hey, I want to get push notifications. The push provider then says, all right, here's a piece of information that identifies this app and your device to me. And if you're looking at Windows or Windows Phone, that's a channel URI. If you're doing Android development, it's going to be a registration ID. And if you're doing iOS development, it's going to be a token. Your app can then send that information up to mobile services. Your mobile service can then take that data and use the push module that I mentioned earlier and say, hey, push provider, send this payload to this channel URI token registration ID. Push provider will then make sure it's a valid, piece of information / the payload is appropriate, and then it will then deliver that push notification down to your application. So we're going to go ahead and show implementing this with an Android application using native development. So the first thing I need to do is open up the Google API console. And inside here, I'm going to create a new application. We'll just call this Build MS. I'll create my project. It's going to take a second. Then after that, I'm going to have to go down and I turn on Google Cloud Messaging for Android. Depending on which platform you're working with, things are a little different. It's all basically the same concept. You kind of need to turn on push notifications slash, sign up for it, and then you get some information that identifies your app to the push provider. So I go into the API access area, and I create a new server key. The server key is going to be what my mobile service actually uses to sign requests to the GCM or Google Cloud Messaging servers. So I'm going to copy this key over to my mobile service. I'll go into the push area. And then down here, this is where I specify that API key. This is also where you do the Windows Store push credentials as well as AP&S settings. So I'll go ahead and save that. So the next thing I need to do is I'm going to go back to my quick start screen because I need to actually download the Android application. So go ahead and create a new Android app. We've already got the tools. We've already got the table. Let's go ahead and download that. So I've extracted that, and now the next thing I need to do is actually import it into Eclipse. So I'll go ahead and import the project, and really quick, let's go ahead and run this so we can actually see what it looks like when we run it in Android. Same to-do list, going to access the same data, so as soon as we open it, we're going to see the exact same data we saw before. After a second, it'll pull that data down at least. So same data. If I want to, I can go in and add an item, and it'll show up on all the other applications just like before. Really quickly, I'll walk through some of the differences in this code versus what we've already seen in the HTML JavaScript side. So here, like I said, instead of doing just pure JSON, we actually have a strongly typed object. This is kind of more or less the exact same thing we'd see if we downloaded the C# Windows Store application or Windows Phone application because they're using strongly typed data. So inside here, I've got my complete property, I've got my ID, and I've got my text. And then I've got annotations that basically say this is how you serialize and deserialize it. This is kind of the same sort of thing you'll see on the .NET side. If I go into the to-do activity, which is kind of what drives the code behind for the UI in this application, we go down here and we have, again, same URL, same application key because it's accessing the same service. When we actually go to, let me go down here. We actually go to an add an item. So instead of creating JSON on the fly and doing an insert on that, we actually create our to-do item object and then set its properties and then insert that. And then when we refresh items, again, things are a little different for each platform. Here we have a method-based approach where instead of doing link like we do in .NET or just doing a JSON query or filter like we did in the HTML.js, we specify things via methods. So .where, .field, and .equals. We all do that to do our where clause. So the next thing we're going to do is actually do a fair amount of work to actually implement push notifications for our application. First thing I need to do, though, is actually drop in the library for push notifications. Now, if that's done, I can actually go and do the code behind for it. So I'm going to refresh just to make sure that library is there. Now, I'm going to open my Android manifest file. And this is kind of like an app configuration file if you're not familiar with Android. But it basically specifies a lot of things about my application, like the permissions it uses, what different things can launch the application, a whole lot of fun stuff. So I'm going to copy some permissions over there. And basically what I'm saying is I'm creating a permission that says I'm going to be able to receive messages. And then I'm also saying I want to request permission to do a few different things like send stuff via Google Cloud Messages. So I need to specify my application package, which is up here, and it's kind of like an app identifier. I'm just going to copy that and paste it right here as well. And then if I go down, I'm going to copy some more into here. If you guys saw the keynote, I think it was earlier today or yesterday where they showed out the push notification stuff with Visual Studio. Slightly a little bit easier to implement that than it is to do push notifications with GCM. Not just quite a right click and say, set me up for push notifications, unfortunately. So down here, I'm saying I'm going to receive messages and I'm going to send them. And then I'm specifying I'm going to create a service file, which will basically be any interaction with GCM. This is the service that's going to do everything. So the way I'm going to do is I'm going to change my to-do item so that whenever I send a to-do item up, it does a push notification down to my application. So I'll go to the to-do item class. I'm going to add a new property for that registration ID. Again, when you do Android GCM, you get a registration ID, and that identifies your app and your device. The next thing I do is need to go back to the to-do activity and add something to A, store the registration ID, and then also a sender ID. So the sender ID is basically how my device identifies itself to the GCM servers with the application I created in the Google API console. So in order to get that, I need to go back over here. I'm just going to grab that from the URL because basically the sender ID is the project ID. So we'll paste over that. Next thing I need to do is actually tell it to register for GCM push notifications. And I'll do that right here before I create my mobile service client. So I've got the first call is to check the device, and then I call check the manifest. Basically what this is doing is just making sure, hey, this application is actually set up to receive push notifications. And after that, I'll go down to when we actually add our item. And after we set the other properties, I'm just going to set the registration ID. And I'm going to do that by calling into a GCM intent service, which I'm going to create right now. This GCM intent service, it's going to implement a class called the GCM base intent service. This class basically has 4 methods that I'm going to implement called onAir, onMessage, onRegistered, and onUnregistered. Basically, these are all the methods that GCM might call on your application. So in here, I'm just going to add some private variables to track a few things. So I've got the registration ID that I'm going to store here. And then when I construct my GCM intent service, I'm going to pass in that sender ID to the super constructor or the parent class constructor. And that's what basically sets us that whenever GCM intent service does something, it uses that ID. So then I'm not going to implement all of those methods today. I'm actually just going to implement the onMessage and onRegistered. OnRegistered is very simple. It's what gets the registration ID from GCM, and we're just going to store it locally. OnMessage is going to use some of the notification stuff within Android to build up a notification, say, hey, you got a new to-do item, make sure it's a high priority, and then get the string text out of the push notification. We then use the notification manager to actually put that into Android's notification system. Now, the last thing I need to do is actually change the script on the server side to actually do a push. So I'll go back to the portal. I'm going to go to the Data tab, go to To-Do item, back to the script. And then here, I'm just going to overwrite everything I've got right now because I don't really care about that validation anymore. So the first thing I do is I execute the request, so insert the item to the database. After that, I've got a success handler right here that says, provided you were successful in inserting the data, call this code. So the first thing we do is respond to our application. So we don't want our application to keep waiting for a response, so we just tell it, hey, we're good. And then we use push.gcm.send to send our push notification. We pass in the registration ID, so hey, GCM, please deliver to this registration ID, and then the text. Let's go ahead and save that. So now we'll rerun our application. It's going to take a while to compile and then actually run. All right. Before we actually get into that actually working, so right here we see that we did actually get a registration ID back from GCM, so this should work. So we're going to test out push. And now what we should see is up at the top, we have this little icon pop up because our push notification showed up. If I pull down here, I can say, oh, yeah, it says new to-do item, and it actually has the push the data that I sent over. So really, really simple to add a single line of code to your scripts and get pushed down to all the platforms. Each of the platforms might have their own kind of method or different ways of doing payload. I know, like, if you do a Windows Store app, there's about 30 different methods because you can send toasts and texts and flip pictures and all sorts of fun stuff. But basically, really easy to do push no matter which platform you're working with. The next thing we're going to talk about is user authentication. Mobile Services has built-in support for Facebook, Twitter, Google, and Microsoft accounts. And it's super easy to add authentication no matter which platform you're working with. It's really kind of like the same exact thing. Once you do have user authentication, you can also take a closer look at data authorization. So when you create a table, there are permissions around the operations for that table. The way the flow kind of works is your client makes a request against your mobile service. The runtime gets that request and routes it to the correct script, provided it meets whatever the operations permissions are. By default, they're anyone with the application key. And as I've pointed out several times, whenever we create our mobile service client, we're doing so with the URL and the application key. What that does is each SDK then uses that application key and puts it in a header for each request. So that's why when we have the permissions as anyone with the application key, all our applications are working right now. Once we actually authenticate users, though, we can look at actually saying only authenticated users should be able to access this table operation. Once you do that, basically, if you're not sending over a user token as a header with each request, it won't get through. The runtime is basically going to block it. You can also say only scripts and admin, so only other scripts, or someone with that master key that I pointed out very early on that was below the application key. If that's not as a header, it won't get through. Lastly, you can also set it to everyone, so as long as you know the REST API, you can access it. Now, I said that user object didn't really have much information before because it just basically told us they weren't authenticated, they were anonymous. Once you actually authenticate, or if you pass in the master key, you can find out that they're authenticated or they're an admin, and then you can also use the user ID. So let's go ahead and actually implement an application with MonoTouch and Xamarin, and then add authentication to it. So the first thing I'm going to do is I'm going to go to the Xamarin Studio, and I'm going to create a new project, or a new solution, rather. So I'll go to iOS, I'll go to Universal, and I'll say I want an empty project. I'm going to put that in this folder, and I'll call this build MS. OK. So in here we've got our basic application. We'll go ahead and we'll run this in the iPhone. But the iPhone simulator doesn't really like to work if something else is using it, so let's go ahead and kill that and rerun it. So right now, it's not actually doing anything because we have an empty project. It's not doing anything at this point. So the first thing we're going to do is kill the application. We'll go to Project. We'll go to Edit Components. And I've already pulled down the Mobile Services component. But basically, there's an Azure Mobile Services component that you just go to their component store and you pull down for free. So we'll add that to our project. Next thing we need to do is need to add a couple references. So we're going to use system.runtime.serialization. That's going to actually handle doing all the serialization for us. And then we'll pull in the MonoTouch dialog, which is going to make it a little bit easier to actually show some stuff. So I'll copy over this code right here and go to my app delegate. The app delegate is kind of like an entry point for our application. So inside here, I'm going to add this new private variable. Now, I need to set my URL, and then I need to go grab the application key. So I'll just do that by going over here and pulling it out of this project. There we go. So I'll set that. And then I need to add a new using statement. So I'll say Microsoft.WindowsAzure.mobile services. Great. Excuse me. Next thing I need to do is add a to-do item class. So I'll go up here and I'll say add new file. I'll go to general. And I'll do to-do item. CS. I'm just going to copy a little bit of code here. So I'll overwrite my class here, and basically I've got the same properties we saw on the Java application, and then some annotations that basically say how should it be serialized. And again, this is C#, so it's basically the same thing we'd see if we looked at doing a .NET app, or like a .NET Windows Store app. So we'll say, oh, actually wrong one, using system.runtime.serialization. So that should work. Now we'll add a new class that will actually be our UI. So we'll go down to iOS and say we'll do a dialog view controller. Say to do view controller. And I'm going to copy a little bit more code over for us. And inside here, I'm going to paste this over this. So, okay. Let's get rid of these using statements. So I know you guys aren't tired of hearing me say this, so well, actually, I've already looked at it. We already have the same URL and service. So we've got our iMobile service table, which basically wraps the to-do item. So when we do this, it says, hey, this table right here, it's going to use the to-do item table behind the scenes. Down here, we use our mobile service that's in the app delegate to get our table. When we refresh items, so this is where we have that link, where we're doing kind of a link-based where clause, as opposed to doing a method-based like we do in Java, or passing over a jQuery object like we did before in HTML.js. Then once we actually get the items back, we populate the items right here. And this is where we're also specifying, hey, whenever you insert an item, this is how we're going to insert it by creating a to-do item object. Go down here. Now we should be able to, oh, one last thing I need to do. So in order to actually use that view controller, I have to go back to my app delegate. And down here, This finish launching method is kind of like the entry point, so it's the first method that gets called inside my application. So inside there, I need to specify, hey, load that for your UI. So we should be able to build our application now and run it. And we get all the to-do items. I can go ahead and say test from mono. So this application is all built in C#, but it's actually running in iOS. So the next thing I want to do is I'm going to go up to the portal, and I'm actually going to lock down this to-do item table. So I go to the permissions for the to-do item, and like I said before, default is anybody with the application key. So let's go ahead and say only authenticated users. So now in order to make it through, I have to send over a user authentication token with each request. So we've saved that. Let's go ahead and restart our application. And now I'm not going to get any data back because my application can't get through. If I actually had some error handling in here, I could actually see I'm getting back a 401. And obviously, if I'm building an application, I should make it so that I'm not getting a 401 because I should be making my users authenticate. So let's go ahead and do that next. So we're going to add some Twitter authentication. So the first thing I'm going to do is go to the Twitter dev portal. I've already logged in. I'm just going to go to My Applications, and I'm going to create a new application. To do so, I need to grab the URL of my mobile service, which I'll get from the dashboard. And we'll call this build.ms. We'll put this in for the URL. And I never put a long enough description, so we'll paste that over a few times. Then down at the bottom, I just need to agree to their terms and conditions, and then hopefully get the captcha right. All right. So authentication is basically the same no matter which of those providers you use. You go into their dev portal, you create an application, you give them the URL for your app, and they give you back two pieces of information, which are a consumer key or consumer secret. Of course, each of the identity providers calls it something different. So we go to our application in the portal, we go to the identity page, and let's go and paste that into the Twitter settings. So we'll save that. Now, I'm going to go back here and I'm going to grab the URL because just like when I create a table and behind the scenes it creates a REST API, when I do that, it's creating an endpoint for my login. So if I go to the URL of my mobile service /login/Twitter, it's going to redirect me to Twitter's authentication page. And that's exactly how we're going to do our authentication within our application. So I'll go ahead and close that. We'll go back to Mono Studio, and I'm going to change a little bit of code. So first thing I'm going to do is go to the to-do view controller. Let's kill that. There we go. And right now, view did load, which is in the view controller lifecycle, it's kind of the first method that gets called once your view is starting to load. Here, we're calling the refresh method, which again does that link statement against our to-do item table and pulls down the data. I don't want it to do that necessarily because I want it to really check our current user. So here I'm saying if the mobile service client's current user project is null, then call a login method. Otherwise, we're fine to refresh the data. So let's go ahead and call that. Or set that up, rather. So this login method is using the mobile service client. It's calling login async. It's passing in the Twitter provider. And then when it gets a response back, we're saying, hey, you've logged in. And then we'll finally call refresh. So let's go ahead and run this code. So we can log in now. And since it likes to show passwords, I'm just going to drag that down there. So it says I've logged in. And now I've got access to the data again. And now what I really want to do, though, is actually when I save data, I should be able to save it and connect it to my account. And then I should be able to only pull my data. So the first thing I'm going to do is go back to the portal. And I'll go over to the Data tab, and I'll go into my to-do item table. I'll go into the script. And now that I'm actually authenticated, this user object right here, it's not just saying I'm an anonymous user. It actually says, A, this user is authenticated, and B, this is their user ID. So inside here, I can take my JavaScript item. Before I actually do the insert to the database, I'm going to specify a new property called user ID on it, and I'm going to set it using the user object. So I'll go ahead and save that. And now if I go back to the client and I say save my user ID, we'll add that item in. It's there. And now if we go back and browse, we can see that the user ID field is there, Dynamics Communication added it, and there's my data. Now as far as actually filtering the data out, I can do it in two different ways. I can go into each of my applications and say, whenever I do a read, add another clause to it where the user ID is equal to the user ID. I've got access to that user ID in each of the clients, so I could do that. But the problem is, especially if you look at stuff like doing JavaScript where you're exposing that code publicly, and it's relatively trivial for someone to look at that and just basically change the query and change what's going on. Basically, then they could just drop that clause and get access to all the data. So instead what we do is we'll do it on the server side by going to the script tab and going to the read script. By default, just sending it straight to the database. But here, instead of a JSON item, we've got a query, and that's basically whatever the query is I send across the wire. So I'm going to add a new query to that. Say where user ID is equal to the user ID that's getting sent in. And now if I save this, I'll go back to Xamarin Studio, I'll restart my application. Only necessary because I don't have some way to just refresh from inside the application. Now, I'm not caching the identity, so it's going to ask me to log in again. I can do that relatively easy, and I'll actually be covering that briefly in a session right after this one. But we'll go down here and we'll log in again. I'm authenticated, and now I only get back the data that's attached to my account. So now everybody has their own data, and I don't have to worry about somebody else seeing my data or me seeing anyone else's data. And this applies basically across the board. So if I go run any of the applications I did before, for example, if I go here and I go back to my list, it's not going to access the data because I'm not authorized here, and it's actually saying, hey, you're not authorized. So once I've locked down an application, anything that was using it before, it won't work until I actually basically enable the access or enable authentication. All right. So command line tools. As I mentioned before, you can get access to the data with command line tools. So you can actually read tables, see the data inside them. You can actually update, delete, change permissions on tables. You can also do a ton of other stuff like create and delete services, create and delete the scripts for those services. You can scale up and down your services, and you can actually do quite a bit more. Let's go ahead and take a quick look at what you can do with the CLI. So inside here, I've already got loaded the tools here. So if I say Azure, I get a list of kind of everything you can do with this tool. And as you can tell, there's actually quite a lot here outside the mobile stuff. There's endless functionality you get from here connected to Windows Azure. If I say Azure Mobile, I get the specific stuff you can do within the Azure Mobile module. So I just want to list out my services. So I'm just going to say Azure Mobile List. And we'll see, OK, there are all my services. And yep, I've got the build MS. So I can say Azure Mobile config build MS. Oh, I think I need to do list in there. And it's going to give me all the configuration stuff for my mobile service. And I can actually change these values too. There's a lot of different fun stuff you can do here. And one of the biggest things, like I mentioned, is scaling as well, because you can script this to basically do whatever you want. So scheduler is what we use to provide back-end processing. And basically what it is you generate scripts that you can either trigger on demand or on a scheduled basis to kind of do whatever you want. Now, the frequency and length of execution, basically how long can you execute a script, depends on what kind of level of mobile service you've got. So under free mode, I think it'll run for quite a few minutes to, I don't know if it actually runs up to an hour, but quite a bit of time. But if you want something that will run for several hours, you go up to the standard, or I think the Premier, or whatever the unit is after that. Those will run for a very, very long period of time. And they also, how long you can, or the period of implementation, so will it run every 15 minutes, every 5 minutes? That's controlled by what level of mobile service you have as well. Custom API is a feature we launched last week. And basically the idea is that you want to expose endpoints that aren't necessarily tied to SQL tables. So these are non-table-based scripts that you can execute via get, post, put, patch, and delete. And basically they have the same permissions as tables do. So you can lock them down to say only authenticated users, just like you can with the table scripts. All of the client SDKs contain the code to execute these custom APIs for you. So that's how it will basically pass over the user credentials whenever you talk to them. We also have script source control, which is new. Basically what happens is you turn this on, and then you get a Git repository, which you can clone locally. That Git repository will contain all of your scripts for tables, scheduler, scheduled jobs, your custom API, as well as shared scripts, as well as JSON files that contain the permissions for your table and your custom API scripts. So you can basically modify all that locally and push it up using your Git repository. Shared scripts is basically a way of making scripts accessible from your other scripts, and it's basically you're creating a node module. So like the modules we have built in, like request and push and stuff like that, those are node modules, and this is a way you can create your own. Now, today, unfortunately, it's not really accessible from anything besides custom API, but we'll be fixing that soon, so you'll be able to access these shared scripts from your table scripts as well as scheduler jobs as well. NPM, likewise, is gives you the actual ability to install pre-built Node modules. So Node is quite a rich ecosystem. It has quite a lot of functionality. And with NPM, you can actually install these modules and then take advantage of them without having to write all that JavaScript yourself. So let's take a look at how some of this stuff is set up really quick. So I'll go back to the portal. And I'm first going to go into the dashboard. And I don't think we have time to really turn it on and take a look at it. But right here, this is how I set up source control. So I click this. It'll create a Git repository, which will then show up, the URL for that will show up under my configure tab. That's how I can pull that down locally. Custom API will generate one of these really quickly, so I'll just call it my API. Again, we have the same permission options we do with tables. Create that API, go in here, and then I can define whatever functionality I want to happen depending on what HTTP method is called. So here I have post, and it just responds with hello world. If I wanted to do a GET on this as well, I could just say exports GET, and this would enable it to do to handle both posts and GETs. And then, of course, you can change the permissions right there. Scheduler, very, very similar. You create a scheduled job, and you can specify the name, how often it should execute, whether hours, minutes, days, and then whether or not it should be on demand or not. And when it's on demand, you can basically just go into the portal and say, yep, run my job whenever I want to. It's important to point out that all that stuff is just as accessible across any of those platforms you're using. So whether you're dropping the code into a Xamarin app, into a PhoneGap app, or you're doing something native, it all works essentially the same way. So as far as diagnostics, logging, and scale goes, you get access to stuff like the API calls, the CPU time, and the data out. Obviously, API calls is kind of important now because we're changing from a bandwidth-based model to an API-based model, which I'll talk about in just a second. Scaling of the service is basically based off of the number of API calls you're going to have per month. Console, you can do logging from your scripts, as well as any errors will automatically be logged. And we'll see that because of how I did my push notification script, I've actually already caused a few errors that I wasn't logging, so I'll go in there and we'll actually look at those. And then you can also scale your SQL database server if that's to provide sole only one database on that server sort of thing. So as far as the service scale goes, and I've got a better chart of this a few slides from now, but there are 3 different modes. There's free, standard, and premium. Free is 500,000 API calls per month for your whole subscription. Standard is 1.5 million API calls per standard unit per month, so that's like basically a specific application, not across the whole subscription. And then premium goes up to 15 million. Let's take a look at some of that stuff. So we'll go to the portal, and first of all, in the dashboard, we see we've got this chart here. We can also configure some more advanced scaling as well, or advanced monitoring as well. If we go over to the configure tab, this is where if I had source control enabled, it would show me the Git repository here. I can change my database. I can turn on and off schema. If I want to push the HTML JavaScript stuff to an actual website, I can enable cores. So right now, the only reason I'm able to run that website locally is because I've already got this set up to say, allow requests from localhost to work. If I push it somewhere like Windows Azure websites, I need to actually put it in the URL of my website in order for it to work here. And then also the monitoring is right there. Scaling's right here. And we've already got the changes in here, so you can go from free to standard and premium. And once you do, you can change the number of instances running your service. You can also scale the database here, as well as going over to the database tab and doing the scaling there. Now if we go to the logs, we'll see I already caused the errors because when I did the push notifications, or when I changed my to-do script to do push notifications, I was just assuming I was going to have a registration ID. But I added more to-do items for my Xamarin app that didn't have the registration ID. But it was still tried to push that out. So it's logging that and saying, hey, there's no registration ID. I can't actually push out to this. So I can know that something's wrong. So preview pricing, I just put this here kind of for historical benefit because it doesn't really apply anymore. Previously, it was all based off instances, which is the same way you look at websites or VMs, whereas now everything's based off API calls. And this is kind of a more defined, there's free, which is you have up to 10 services and up to 100 active devices, and you get 500,000 API calls, whereas there's standard and premium, which are units, and then obviously it ups the number of units. There's no device restriction limit. Scheduled jobs, you get to do much more and much frequently use those as opposed to when you're under free mode. And then the SQL database is considered separate, but we do now have the free 20 megabyte SQL database, so you can effectively develop without having to worry about paying for stuff. So since we're definitely out of time, In summary, Windows Azure Mobile Service is a backend as a service. Gives you access to a ton of great features no matter how you're building your app, such as data storage, push notifications, user authentication and data authorization, server-side logic, scaling, logging and diagnostics, as well as backend processing. And it works kind of no matter what platform you're building on because there's an SDK that works for it. And even if you're building something that's not shown here, the REST API is a REST API, and as long as you can make a web request, you can talk to it. So I've got a few resources here. If you go to windowsazure.com, you can sign up for a free account. If you go to www.windowsazure.com/mobile, you'll get taken to the Mobile Dev Center where there's tons of videos and tutorials. I think if you enter that without the www, it won't work because redirections are hard, I guess. All of the SDKs for mobile services are publicly available on GitHub. So if you want to understand how something works, if you want to change it, implement it your own way, do anything like that, it's all available there. You can pull it down. You can pull down the test projects for it. You can see how all that works. And if you just go to GitHub and search for Azure Mobile Services, you'll find it. As always, you can contact me. I've got my website and my Twitter handle there if you ever have questions, issues, concerns, or thoughts about mobile services. We've still got another day of build left, and there's quite a few sessions left. So you've already missed, if you didn't go, Josh Twist's session earlier today. You're at the cross-platform session. Immediately following this, I'm giving a session on pro tips where it's kind of covering a lot of the stuff that we don't really have a lot of documentation around, but stuff that people ask about quite frequently. There's a phone apps session tomorrow as well as a Windows 8.1 app session. The Going Live and Beyond talks about kind of how to do stuff that once you're ready to launch your application in production, like stuff you should be concerned about, like how do you do script versioning or how do you do like staging environments, stuff like that. They'll talk about those things. As far as push notifications go, the way I implemented it here, it was kind of specific to Android. And I can certainly handle it, across the board, for different platforms, and I'll show that in my next session too. But there's also something called notification hubs, and Elio's doing a presentation tomorrow at that at noon, and it's going to cover how to do push notifications to millions of devices and users using notification hubs. There's a session with some more advanced user stuff called Who's That User at 2, and then also at 2 is that Windows 8.1 with mobile services session. And I know Nick's going to talk about some geolocation stuff there and some other fun stuff, so it might be worth checking out. So thank you, everybody, for coming. I'd love to take any questions. Just come up to a microphone if you have one. Yeah.
Hi, Chris. I noticed that all your server-side code was in Node.js and JavaScript. Can you do that same server-side code in C#?
Yeah, so the question was, all the server-side code I showed was in Node.js and JavaScript. Can you do the same from C#? Today, you are using Node.js and JavaScript. There's no C#. We've certainly heard that from a lot of people, and there's a lot of interest around that. So it's something we're looking at. I just don't know if/when we're going to implement it, but that concern has been heard, and we know.
All right, thank you.
Yeah, no problem.